not even related. They don't, maybe they have one or two things in common, but they are not related at all, at all. They are completely different. Okay. The only reason why Mocha was renamed to JavaScript was for marketing purposes. So that was the only reason why Mocha was renamed to JavaScript. That was purely for marketing purposes. Okay. So now we have this particular programming language called JavaScript. Now Microsoft loved this idea of scripting language to add interactivity to web pages because they saw that developers were using this new language called JavaScript to add interactivity to web pages. Okay, so they decided to create a programming language, or rather to also create their own scripting language for their own web browser. So the Microsoft's web browser then was called Internet Explorer. So what did Microsoft do? Microsoft reverse engineered JavaScript and created a programming language called JScript. Okay, so you can search for that, guys. I'm not making this up. They created a programming language called JScript. So Microsoft, they reverse engineered JavaScript and then they came up with a programming language called JScript. So JScript was the programming language that you're supposed to use to add interactivity to web pages that were meant to be displayed on Internet Explorer. And then JavaScript was the programming language that was supposed to be adding interactivity and functionality to web pages that are supposed to be displayed on Netscape Navigator. So it became pure madness at that particular point in time. Okay, because the languages, those two programming languages, they look awfully similar. Like they look very similar, but they behave in a very different way. Okay, so it became pure madness because this is what developers had to do. You as a developer, you're supposed to write JavaScript to be executed in Netscape Navigator, and then once you're done, you rewrite the same JavaScript to be executed in Internet Explorer. It was pure madness, and developers were almost giving up. So that is where now the Netscape Navigator company, wanted to do away with this madness. So they approached a company called ECMA. Okay, they approached a company called ECMA. You can search for that company. They approached a company called ECMA, and they gave this ECMA company JavaScript, and they asked the company to standardize that. Okay, so they asked the ECMA company to standardize the JavaScript programming languages. And so now ECMA started working on a JavaScript standard. So when I talk about a JavaScript standard, I'm not talking about a programming language or a new programming language. I'm talking about a specification of what is supposed to happen. So it's like ECMA is this middleman who is trying to resolve this conflict between JavaScript and sorry, not JavaScript, yeah, JavaScript and JScript. So this ECMA over here was like that middleman who was trying to resolve that particular difference between JavaScript and JScript. Okay, so for example, they were telling, by the way, guys, before we continue, before we get to that, there is a term I want to define, and that particular term is a JavaScript engine. So a JavaScript engine is basically a piece of software that is used to execute JavaScript. Okay, so now back to what we're talking about. This ECMA company, they started to standardize JavaScript. So basically, when we talk about standardizing JavaScript, they, for example, bring the engineers for Internet Explorer, the engineers who want to write JavaScript for Internet Explorer, and the engineers who are trying to basically build JavaScript for Netscape Navigator. And they tell them, for example, a keyword like push is supposed to behave in a certain way, or a keyword like let is supposed to behave in a certain way. Okay, so ECMA, whatever we're referring to as ES, this particular ES is what was born out of this, ECMA company trying to standardize JavaScript. Because guys, we have a lot of JavaScript engines out here. Okay, and all of these JavaScript engines, they use this ECMA specification to know how to write JavaScript. As time goes by, when you guys understand what you mean by a JavaScript engine, you will now understand perfectly fine what you mean by this ES or ECMA script. Again, a JavaScript engine is basically a piece of software that is used to execute JavaScript. Okay, so that particular piece of software, it takes in JavaScript code and then gives out some sort of a JavaScript output. And each browser has its own JavaScript engine. Each browser has its own JavaScript engine. For example, the JavaScript engine used in the Chrome browser is V8. Okay, so that is the JavaScript engine used in the Chrome browser. It's called V8. I'm not making that up. You can go search for it. The JavaScript engine used in something like, let's say, Mozilla Firefox is called SpiderMonkey. The JavaScript engine that is used in something like, let's say, the old versions of Internet Explorer was something known as Chakra. I can't remember well, but I think it was something known as Chakra. Okay, so you as a developer, you're supposed to follow this particular standard called ECMA in order to come up with your own JavaScript engine. So this ECMA, whatever you're referring to as ECMA, it's not a new programming language. It is not a replacement of JavaScript. It is basically a specification of how JavaScript is supposed to behave. So let's say, for example, right now, Kibet decides to build his own browser, and he decides to write his own JavaScript engine from scratch. Okay, so you not just come up with your own way of JavaScript working. You're supposed to follow the ECMA specification. So this is that particular specification that we're talking about. Okay, so this is the ECMA specification. You know, it is basically a standardized version of JavaScript. So if, for example, the developers who are building the JavaScript engine for let's say something like Mozilla Firefox, which is the SpiderMonkey JavaScript engine, they're supposed to follow this particular standard to know how various methods or how various functions or how various keywords are supposed to behave. Okay, because it used to be madness. Because at that time, you can imagine, for example, we had JavaScript and then you had JavaScript. So the developers were running into these weird behaviors where, for example, the push method in JavaScript works completely different from how the push method is working in JavaScript. And it was a lot of madness because you're writing the JavaScript and it's working very fine in something like, let's say, Microsoft Internet Explorer or other Netscape Navigator. But the same JavaScript cannot be executed well in something like let's say what Netscape Navigator. So this is what developers had to do. Let's say you want to add an element at the end of the array. So you as the JavaScript developer, you have to check the browser you're working with. So you have to check here, for example, if okay, I'm just trying to write here pseudocode. I'm not saying that this is how the code used to look like. So if browser is equal to Internet Explorer, okay, then you have to write how adding an element at the end of the array would work. Okay, so maybe something like array.append. I'm just coming up with a word. I'm not saying that this is something that probably doesn't exist. I'm just trying to show you guys what used to happen. And then you're supposed to write something like else if the browser is equal to let's say here Netscape Navigator. Then you write a completely different JavaScript to basically do whatever is supposed to be done there. Maybe now for the Netscape Navigator it's array.push. Okay. And if ECMAScript did not chip in to solve this madness, it will become very mad. Right now, you'll be writing JavaScript. For example, that's what the persistence thing we're working on. You'll be writing that particular piece of JavaScript to run in Internet Explorer. Okay. But when it comes to Google Chrome, then the next keyword, for example, does not work how it was intended to work in. Let us just say here that number is equal to 25. Okay, so you'll be writing a piece of JavaScript code, okay, and the JavaScript code will work perfectly fine in let's say something like Netscape Navigator. But the same piece of JavaScript code, if you try to use it on a different browser, you end up realizing that it doesn't work the same way. So Netscape, Netscape decided to give JavaScript to this company called ECMA to basically standardize JavaScript. And so ECMA came up with this standard, which is what we refer to as ES up until today. So you can see this is just a specification. So if you want to create your own JavaScript engine, you're supposed to follow these instructions here. Okay, that way JavaScript behaves the same way across all environments. For example, I can try to search here for the push method of arrays. Okay, the one that we've been talking about. So I'm trying to search here. For example, you can see here, this is the array push method. You can see it's a specification telling you what you're supposed to do. So you're Tibet, you want to build your own JavaScript engine. And you now want to implement this method called push. You can see there is a specification telling you how the method should behave. So this method appends the argument to the end of the array in the order in which they appear, and and then it returns the new length of the array. And you can see this is what they're telling you is supposed to happen for you to implement this method. So if you're trying to build your own JavaScript for your own browser, this is the specification you're supposed to follow. So at the time you're writing the push method, you now follow these instructions over here. Okay, as you can see, it is a specification. It's telling you how JavaScript should behave. And basically, that standardization is what now is making the web today to be very easy to work with. It's just a specification. Okay, I want you guys to assume that let's say Winnie discovers a vehicle today. Let's say we don't have a concept of vehicle, but Winnie discovers the concept of a vehicle. Okay, so for Winnie's vehicle, for you to drive, you're supposed to use a steering wheel to basically be able to steer the car to the left, to the right, or forward or backward. And then Joshua looks at Winnie's idea and is like, you know what? I can also build such a thing. So Joshua comes up with his own car, but now to drive Joshua's car, you're supposed to use a button. You press the forward button, you press the back button, you press the left button, you press the right button. Okay. Then who else? Let's say Aitotia sees the same idea and it's like, you know what? I also want to build my own car. So Aitotia comes up with her own car where you direct it using a language. For example, you turn it left and then it goes to the left. You turn it right and then it goes to the right. You turn it forward, it goes forward. You turn it backward and then it goes backward. Okay. And then somebody else, for example, let's say Winfred. Winfred decides to come up with her own car where for you to drive, you're supposed to maybe use a laptop or a phone. Okay, so you use your phone to control your car to move forward, to move backward, to move left, or to move to the right. Now, what will that mean to a person like me who wants to learn how to drive? To a person like me who wants to learn how to drive, I now have to learn like 10 different ways to move a car. I have to learn Winnie's way, Winfred's way of moving a car using a phone. After that, I enroll on a different driving school to learn, you know, Winfred's way to move a car. After that, I enrolled to a different school to learn Joshua's way to move a car. After that, I enrolled to a completely different school to learn Aitotia's way to drive a car. And you can see that's a lot of madness. But now you can imagine the four of these inventors, they come together and they decide to create a standard. Okay, so they submit that particular idea of a vehicle to a company, and then this company comes up with a standard. So this standard, for example, will say if you want to create a car, okay, if you're a person who wants to build a vehicle, for this vehicle to move forward, this is what is supposed to be happening. For this vehicle to move backward, this is what is supposed to be happening. Now, all the other car manufacturers, for example, let's say Patrick, if Patrick wants to manufacture a car, he's supposed to follow that particular standard. So if he wants to manufacture his car to move forward, he's supposed to follow that particular standard that, Winnie and all the others agreed on. So this is what you can see is the standard that we're talking about here now. You can see they're telling you how the push method should work. So you as the browser developer or you as the JavaScript engine developer, if you decide to use Python to implement this push method to behave like this, it's 100% okay. If you decide to use C++ or C Sharp, as long as at the end of the day it behaves like this, that is 100% okay. So I hope you guys get the idea behind this ES or ECMAScript. Okay, so if we have anyone inside here who wants to build their own JavaScript engine, but guys, I keep telling you this, a JavaScript engine is basically a piece of software that executes JavaScript code. And we have lots of JavaScript engines. Okay, so you can just search here for JavaScript engines. We have a lot of JavaScript engines. You can see we have V8, which is what Google Chrome runs on. We have JScript, which is what Internet Explorer used to use. We have SpiderMonkey, which is the Mozilla's engine. We have this Linear B, which is used by Opera. We have GNU Guide, I don't know what that does. We have this Rhino. You can see we have a lot of JavaScript engines out here. Okay, we have Chakra for Microsoft Edge, as I told you guys. We have this Futak for Opera. I don't know, another Karakan for Opera. So we have a lot of JavaScript engines. All of these JavaScript engines, they have been built different. Probably V8 has been built with C++. Okay, maybe JavaScript was built with Python. I'm just trying to make, I don't know the technologies they're using, but I'm just trying to give you guys an example. Maybe V8 was built with C++. Maybe this GNU guide is built using Python. Maybe Linear is built using Rust. But at the end of the day, the piece of code will work the same way in V8. The same piece of code will work the same way in JavaScript. The same piece of code will work across all of these engines. Why is that? It is because of this standard over here called ECMA. Okay, this particular standard is basically what is telling all of these JavaScript engine developers how they're supposed to implement the JavaScript engine. So if you want to build the push method, this is how it will work. You want to build it with C++, that's your problem. You want to build it with C, that's up to you. You want to build it with Rust or Go, that is entirely up to you. But at the end of the day, this is how that particular method should behave for us to consider that JavaScript. And as you can see, this is what we refer to as the standard. And this now is what we mean by ECMAScript or ES. So when Netscape Navigator gave this, JavaScript, sorry, when Netscape Navigator gave JavaScript to ECMA to standardize, ECMA started doing this standardization, okay? And with each standardization, they usually release that particular standard. So we had ES1, we had ES2, okay? And then I think we had ES3, and then from ES3 they could not agree about some features and so on and so forth. And I think we jumped to ES6. I can't remember the history well, but it's irrelevant. In fact, everything I'm telling you guys about the history of this ES6 or rather this ES is completely irrelevant. So what we're trying to say is this. ECMAScript evolves over time with new features and improvements being added through successive versions. So major versions of ECMAScript are often referred to by their release year. So from the very first version of ECMA, we had that ECMA 1, ECMA 2, ECMA 3, and so on and so forth. But the biggest standardization that ever happened was this ES6, also known as ECMAScript 6. That was the biggest standardization of ECMA that ever happened, and it happened in 2015. I think most of you were in class 8, most of you were doing whatever you were doing, but this is when the biggest version, or rather the biggest release of ECMA happened. It was ES6 and it happened in 2015. So basically each new version introduces new language features, syntax enhancements, and improvements to existing functionalities. And code written in older versions of ECMAScript is usually supported or able to run in new versions of ECMAScript. And this is what we refer to as backward compatibility. Okay, so in programming or in tech generally, whenever you have an old version of a software, let us just use a programming language. Okay, whenever you have an old version of a programming language that will still be supported in newer versions, or whenever you have an old syntax that will still be supported in newer syntax, then that is what we refer to as backward compatibility. And it's a very important thing we'll be talking about this here, guys. So we will be going through some of the most important or notable features that were introduced in ES6. So I hope you guys will have a rough idea of what we mean by ECMA, or rather ES. It is basically a standard. It is not like a new programming language or anything in those lines. It is a standardization of JavaScript. So if you want to build your own JavaScript engine, then you are supposed to follow this particular specification. You're supposed to follow this specification. You can see all of the methods that we learned the other day. Last 3 lets off. They're basically telling you what the method should do and how the method should behave. And by the way, this standard, I think it's open source, if I'm not wrong. Just a second, guys. It's open source. You can find it on GitHub. That way, even you yourself, if you want to contribute to this JavaScript, I'm trying to look for their GitHub repository. Just a second, guys. Okay, I can't find it. But this standard over here is open source, which means that if you want to propose your own changes to JavaScript, okay, you can do that with this ECMAScript over here. I think it's supposed to be TC39. Let me just try to search for this, guys. Just a second. That way you guys will see what you're talking about. github.com/TC39, if I'm not wrong. Yeah, exactly. So this is that open source TC39. Okay, so this is where you're supposed, if you want to propose changes to the JavaScript or programming language, it's not like you come up with a new programming language or anything in those lines. No, what you do is that you you propose a change to this particular standard. And now the JavaScript engine vendors, for example, Google Chrome, V8 or Google Chrome, SpiderMonkey for Mozilla, and so on and so forth, they will now follow this particular standard. So you can see you basically make a proposal. For example, what do you want to be added and so on and so forth. Okay. So I hope you are getting what is happening. So this is just a standard. It is not like a new programming language or anything in those lines. It's basically a JavaScript standardization. And I've given you guys that very nice analogy when it comes to driving cars. And by the way, standards are everywhere. I want you guys to imagine, for example, I want you to look at your laptop, the Ethernet cable, the Ethernet port for your laptop, whether you are using HP or you are using, what other ASUS, or you're using Dell, or you're using whatever it is, whatever laptop you're using, I want you to look at the USB port. It's going to be the same across all the laptops. I want you to look at the Ethernet port. It's going to be the same across all the laptops. Same thing to the charging port. Okay, maybe there might be one variation or two to the charging port, but the idea is the same across all the laptops. It's not like if these laptop vendors, if they build, the Ethernet port in a different way, it will not work. No, it will work perfectly fine, but they are following a standard. There is a standard somewhere specifying what an Ethernet port should look like. There is a standard somewhere specifying what a USB port should look like, what a USB cable should look like. So if today George decided to come up with his own laptop company, to start manufacturing his own laptops, then he's supposed to follow that particular standard. So that all the Ethernet ports are the same, all the USB ports are the same, and that makes it easier for the end user to use this particular product. Okay, otherwise it will be a lot of hell if we didn't have a standard. It will be one hell of a, something that is very hard to explain. You can imagine you have your laptop and then you have your Ethernet cable, and then when you get a new laptop, the Ethernet port is completely different shape. So now you have to undo your whole Wi-Fi installation to support that particular Ethernet port. And then after that, you buy a new laptop. So that particular new laptop, they have their own shape for the Ethernet port. So now you have to do again to undo your whole Wi-Fi installation and so on and so forth. But thanks to standards, all of these vendors are supposed to follow, that particular standard for them to basically do all of these things. Yes? No, they're same all through. Maybe just one or two difference in functionality, but
I have a RAM. I wanted to add to this one,
yes.
but it is not compatible because it cannot fit into that port.
Maybe, yeah, I think maybe something was happening that we're actually not seeing something.
Yeah, the RAM is not for that generation of board you are using.
Yeah,
It's
maybe,
the
yeah.
business versions.
Yeah, exactly. I think it's something to do with that.
No, the 7th generation is the same. Not yet. 6th generation is based on
Yeah, so
I think RAMs change a lot, but the USBs don't.
yeah, that's what I was trying to say. Okay, I'm not too much of a technical, when it comes to RAMs and ROMs and Ethernet and all of those things. But what I was trying to say is the standard. Okay, whether you create your own Apple device or your own Raspberry device or your own XYZ device or your own Dell device, the USB port, for example, you notice is the same across all of those devices. It's not like the Dell company cannot come up with their own idea of a USB port. They can come up with their own shape, their own style, and their own everything. But that will make it hard for you as the consumer because you will have your flash disk. Okay, you'll be able to use it in your Dell laptop, but when you buy another laptop, you cannot use it in that particular laptop. So to make it easier for consumers, we now have these standards, and now ECMA, or rather ECMAScript, is now the standard for JavaScript. They're basically telling JavaScript the same way, for example, there's a standard telling laptops a USB port should be rectangular in shape, for example. Okay, so even this ES6 is telling all the JavaScript vendors, or rather all the JavaScript engine vendors, hey, if you want to build a JavaScript engine, then this is how a certain function should behave, this is how a certain thing should behave, and so on and so forth. So I want us now to start looking at the features that were introduced in this ECMAScript 6, just some of them. We have a lot of such features, okay, that developers really agreed with, that developers really love, but we'll just be looking at a few of them. I'm very sorry guys, we've taken a whole 30 minutes to discuss what the ECMAScript is. Please, when you get the recording, you can skip this part because, you know, you don't really need to understand the history of ECMAScript for you to work with ECMAScript. I was just trying to give you guys a little bit of context. That way you understand how we got here. So when you get the recordings, feel free to jump this part. It's not that important. So the first feature that was introduced in ECMAScript 6 was let and const. So before 2015, we didn't have the let keyword and we didn't have the const keyword when it came to variable declaration. So before 2015, by the way, guys, all the features I'm going to learn from here, all the features that I'm going to talk about today, they were introduced in ES 2015, ECMAScript 2015, which means before 2015, we didn't have these features. Okay? So before 2015, developers were using the var keyword to declare a variable. Okay? So developers were using the var keyword to declare a variable. So the var keyword didn't have this block scope. And by the way, the block scope is a very important thing in programming to avoid some very weird errors. So before 2015, developers were using the var keyword to declare a variable. So if you wanted to declare a variable called age, you had something like var age is equal to 25. So this was the old version of JavaScript before 2015. And of course, it used to work perfectly fine. I can console.log the value of age, save that, and if I execute it, no index.js, you will see it's going to work perfectly fine. Okay, you see I'm getting there 25 and it's 100% perfect. So that is that was the var keyword. Now the problem with this var keyword is that it was not block scoped. Okay, which means if I had something like this, if let's say true, variable age is equal to 25, I could be able to access this particular variable outside of this block over here. Remember I said in programming, a block is basically anything between opening curly brace and a closing curly brace. That is what we mean by a block in programming. Okay, so the var keyword did not support this block scope variables, which means you could access a variable outside of that particular block. So right now, if I console.log here, if I console.log the value of age, you will see it is just going to work perfectly fine. You can see I'm getting 25. But this is actually not an intended behavior in programming. The developers actually like variables being block scope. If you declare a variable between a block, it should not be accessible outside that particular block. So before 2015, developers were using the var keyword to declare variables, to declare variables. Okay, and there's a very important thing that guys need to understand. The let and the const keyword, as we saw before, they are block scoped. So whatever variable you declare using the let keyword or the const keyword, that particular variable is a block scope variable, which means you cannot access it outside that particular block. For example, this opening curly brace all the way to this closing curly brace is the only place you'll access it. So you can see this code over here has worked perfectly fine. Okay, but if I was to change this to be a let variable, a variable declared using the let keyword, then it's only a block scope variable. You cannot access it outside of these blocks over here. So if I save this and I try to execute this, I'm going to get an error. So that is the let keyword, and the const keyword behaves the same way. The only difference is that the const keyword is for variables that should not change. Okay, so if you want a variable that should not change in the future, then you use the const keyword. And then we have a very important thing here that usually comes up in interviews. So unlike var, let declarations are not hoisted. So there is something called hoisting, which was a behavior with this var keyword. Okay, so hoisting is JavaScript default behavior of moving functions and variable declarations to the top of their scope, meaning that functions declarations can be called before they appear in the code, and variable declarations, you can see it's variable declarations, not assignments, are moved to the top of their scope. Okay, so we'll come back to look at this hoisting, but basically what you're trying to say is that hoisting is a JavaScript default behavior of moving functions and variable declarations to the top of their scope, meaning that function declarations can be called before they appear in the code. Okay, you can have something like this, which is maybe here by the way, guys. I can have a function called maybe say hello, and this function maybe what it does is that it logs to the console hello world. Okay, so you can call apparently you can call this particular function before you declare it. You can see I'm calling the function before declaring it. Let us see if this is going to work. Okay. So node index.js, and you can see it's working perfectly fine. Okay, so this is a feature in JavaScript, guys. This is what we refer to as hoisting. You can see I'm calling this particular function before I even create it. This is what we refer to as hoisting.
Is that important?
I don't think this is important. Actually, I believe it's a very bad practice. It's something you should always avoid. So, again, guys, as I told you guys, JavaScript was only built in 10 days. So, Ben and I, made some few mistakes, but either way, if it's working, it's working perfectly fine. Okay. So JavaScript has a lot of weird things, and this is one of the weird things. But don't do it. Just don't do it. Why are you doing such a thing when you know it's going to be problematic in the future? So this is what we refer to as hoisting. Okay. So hoisting is a JavaScript behavior of moving functions and variable declarations to the top of their scope, meaning that function declarations can be called before they appear in the code. As you can see, that is what we have done, and that is because of hoisting. And on top of that, variable declarations, okay, variable declarations, not assignment, are also moved to the top of their scope. So let me try to see if I can reproduce the one for variables. Okay, so you can see this is what we refer to as hoisting. For example, I'm able to call this particular function before I even create it, but it's something I don't think we also have variable declarations. I can have something here like variable age. I have just declared that particular variable. Guess what, guys? I can use this variable before declaring it. Okay? When I use the var keyword, so console.log the value of age. So if I save this and I run this code over here, you will see I will get undefined. By the way, undefined is not an error. Undefined is a very valid value in JavaScript. So you can see apparently this is working, and the developers are getting disgusted with this. Why am I able to use a variable before I declare it? Okay, this creates an opportunity to introduce a lot of bugs in your program. But guess what? When let came in, you cannot do this nonsense with let. Try to declare this variable with let, and then you try to access it before declaring it. Let us see if this is going to work. You see we get an error. Okay, so var declarations, again, this is just declaration, not assignment. Var declarations are hoisted, which means you can use a particular variable before you even declare it. Okay, like I don't know what can you say? It's like you trying to spend your own money before you are paid. Does that make any sense? Guys, does that make any sense? No, it doesn't make any sense. What money are you trying to spend and you won't be paid yet? It doesn't make any sense at all. But for the var keyword, it will allow you to do that. Okay. And guys, again, when you come across undefined, this is not an error. It's a very valid value in JavaScript, which means your program is working. But of course, maybe depending on your context, it could mean an error. But in this case, it's not an error. It's a very valid data type in JavaScript. So you can see I'm trying to access the variable age over here before declaring it, and it's working perfectly fine. This is what we refer to as hoisting. And whenever you declare a variable using the var keyword, then you can hoist that particular variable. Okay? You can see this is what we refer to as hoisting. Whenever you declare a variable using the var keyword, you can hoist it. You'll see our program is working perfectly fine. But if I try to declare it using the let keyword, okay, it will not work. I will get an error, reference error, cannot access age before initialization. And basically, this is how a programming language should behave. Yes, guys, whatever you're seeing here, this is how a programming language should behave. But before the standard, it was just its own things that were happening here. Before the standard, that was very, very valid. Okay, it was 100% valid. But after the standard, let and const came into play. And let and const they tell you no, you cannot hoist a variable. We won't allow you to do that. Okay, and I've given you guys a very perfect analogy. Hoisting is equivalent of spending your own money before you're paid, and I don't know how that is going to work. Okay, but when it comes to hoisting, that keyword is what we use to do hoisting. But the left keyword and the const keyword, they won't allow you to do hoisting. Okay. So I hope you guys got the idea between the let and the const keyword. So the let and the const keyword, they are block scoped, okay, which means whatever variable you declare between those two blocks is only accessible within that particular block and nowhere else. But okay, that was the first thing, that the let and the const keyword, they are block scope, and then we have the var keyword. Okay, the var keyword is hoisted, but the let keyword is not hoisted. So again, the let and the const keyword, they are block scoped and they are not hoisted. Let and const, block scoped and not hoisted. But the var keyword, it is not block scoped and it is hoisted. And hoisted is a very, very bad thing, guys. Okay, it's something you never want. And then the const keyword is basically very similar to the let keyword, only that you use it to declare variables that should not change in the future. So I cannot have something like this. I can have something like this. I can have that age is equal to 25 and then update age to be equal to 30. This is 100% okay. Okay, you can change the variable later on. But with a const keyword, I can have here const age is equal to 25. And the moment I do that, I cannot change the value of this age over here. Okay, I cannot come here to say that age is equal to 99. This is illegal. If I try to execute this piece of code over here, I'm going to get an error called assignment to a constant variable. So that should never behave in that way. And I believe, guys, if you try to look for that in this standard, you will get it. Okay, so if you're a JavaScript developer, if let's say you are, Victor Muli, you want to build your own JavaScript engine, then you're supposed to follow the standard for this let and const keyword. You can see what the standard is saying. The standard is saying that let and const declarations define variables that are scoped to the running execution constant. Okay, of course, they're using very, very technical jargons over here. Okay, but I think you guys get the idea. Okay, so maybe just to give you guys an even clearer context of what you're talking about, I can have the add function, a function called add for adding two numbers. Okay, not an event listener. A function called add for adding two numbers. So A and B for adding two numbers. So maybe according to my standard, this function should return the sum of two numbers. Okay. So you will find that maybe this function, Kibet is going to execute it like this, return A plus B. Okay. Maybe Joshua is going to execute it like this, function add A comma B. Okay, maybe Kibet will, oh, sorry, not Kibet, maybe let's say Joshua will return here math.sum. Okay, do we have anything like math.sum? Okay, maybe we don't have anything like math.sum, but you can just assume that we have such a thing, A comma B. Okay, maybe I taught here, I decided to execute it like this. So function add A comma B, maybe return B plus A. Okay, so you can see the standard. The standard specifies that the add function should add two numbers.